So very short, so this is my agenda. First, so advantages and benefits of KNX in general. And then well, some technical, let's say, explanation, so to explain you the concept of a KNX installation, where we indeed can distinguish devices from objects. But of course I will explain when I get there. And then I specifically want to use the concept of RTC, so that's room temperature control, as introduction for, let's say, the real thing, because this will be theoretically, and then I will give the floor as the way Christian, well, the expression that Christian used. I will give the floor to then the member company here that will present then the real devices. Okay, so let's start. Advantages and benefits. So therefore I simply used this, let's say, this simplified KNX installation. So what is this actually? So we see a bus cable here. So that's a twisted pair 1 bus cable, a low voltage, to which we connect a number of devices, which are actually microcontrollers that are interfacing, in these examples, well, push buttons. So, so symbolically here, this pulse signal is used in order to symbolize rockers, and they operate here this relay, which is also connected to a microcontroller that then operates a light or any electrical consumer actually that is based on switch on, switch off. This is of course just to explain you our principle. So what is the advantage of such a system? Well, that the cabling is really easy. Easy means that it saves time, and therefore the cabling aspect of a KNX system or a KNX installation, KNX network if you want, is cheaper, because yeah, it's really easy to set up. Because extending this installation here with yet another microcontroller, or let's say with another function here, is really easy. So that is actually I think the connection was lost. Could you please, via chat box, confirm me that you still hear me? Okay, you can still hear me. Okay, fine, thank you. Because the connection was broken, I have seen that. Okay, where was I? Yes, so the flexibility aspect, so it is really easy to add more sensors, more actuators. And also, not to forget, of course, not unimportant, is that there is a separation between power and operation. So that is something that we clearly can see here. So there is the mains here that operate, of course, that is used for the electrical consumer, but it's completely separated from the bus. And that is also not an unimportant aspect of the practical advantages of a KNX system. Sorry. So, and there's more to say. So KNX also means automation, and that has certainly some number of benefits. So the automation aspects that I'm talking about is presence simulation, presence detection, so like occupancy. Is someone there? Is someone? Is the room completely empty? Astronomical time can be involved, like sunrise, sunset, daylight availability, alarm conditions, so that that triggers come from a fire alarm, from HVAC systems. Timers, number of timers can be used, like typically for a staircase function, where the light will be switched off after some threshold. After a certain time, I mean. The result of all that is actually that we have the following aspects in the KNX system, and that are the safety aspect, the convenience aspect, and of course, not to forget, the energy efficiency aspect. It's also thanks to that automation well present in a KNX installation. A KNX installation is indeed a collection of devices and objects. So I'm here in the second topic. That means I'm going to explain to you what is the concept actually of a KNX installation. So first of all, well, let's look at a device like this. I present it as a rectangle, right? So that means a KNX installation is actually this. It is actually a collection of these rectangles, or a collection of devices, of course, right? But of course, each such device has at least one data point. Otherwise, there's not much. Otherwise, such network, of course, doesn't make much sense. So there's at least one data point on each device. So which means if I look at the other devices, I of course get more data points. And this is exactly the point I wanted to make. Actually, when we look at it, we can see this, but we can also see this. So that means we see devices, but we can, but at the same time we can also look at the KNX installation like this, like a collection of data points. These data points are in a KNX installation or in a KNX system. They are actually called group objects, or just the term objects is also used. So we understand devices, we understand objects. Then let me introduce yet a new term that's called a group address. And a group address is actually a device-independent virtual link between objects. So an example could be this. So we see here indeed three objects that are now in yellow. That means I have used indeed a group address 1, in order to link these objects together. They form together a function, or at least a part of a function. And blue could be another example. So this could be group address 2. So where we indeed see a link between 4 different objects. Now, this brings me to RTC. Well, obviously, understanding this will help me further explain the following. So, room temperature control, which again is then of course, the introduction for our member company. So here we see for room temperature control, I have two variants. So variant 1 is what I try to explain here. So so behold again these devices. So these are 3 devices in total that I need in order to set up a room temperature control function in a KNX installation. So what is that? Well, I have put it here on the slide as well, of course. So PB is the abbreviation for push button. BI is what I will not use now, right now. That will be for the next slide. RTC is the room temperature controller, and SV is then the abbreviation for switching valve. Well, actually that's the switching valve operator, or the switching valve activator, maybe better said. The actual valve is of course controlled by this device. Then, well, I see then a number of objects. So 1 object on the push button, 2 for the RTC, and 1 for the valve activator, maybe I can call it. And I will use in total actually 2 links in order to set just 2 links. That's all it takes in order to set up a room temperature control system actually. Well, this first link, so that's definitely the link between the push button. So there's a specific rocker that I used, and I linked that to an object of the RTC, and this link will allow me to control indeed via this rocker the day or night mode of the heating system, or the room temperature control system. Of course, it could also be used for cooling, of course. So that is the first link that I need. This is just a 1-bit object, and that will indeed allow me to activate or put the heating system, let's say, in comfort mode. Second link that I will need is between the RTC and so the room temperature controller and the valve actuator, and that is also a 1-bit object, or this is a link between 1-bit objects, and that is also actually based. So that means that the heating system here is based on switching. So indeed, if the heating system or the room temperature controller, better said, is put in comfort mode, and there is indeed heat required in order to increase the temperature, or maybe there's some cooling capacity required in order to decrease the temperature in the room, then the RTC will then indeed switch the valve opens the valve, of course, so that indeed either heat is added or heat is taken away from the room, so to say, in order to control the temperature. Then variant 2 is actually where we have 4 devices involved. So we again see the push button appearing here. As I said, now also we have additionally a binary input. We have RTC, and we have also here a valve actuator. However, this is a proportional valve, so it's a bit different. First of all, again, we need the link between the push button or the rocker and the RTC system, so to put it in comfort mode. I know you know that by now, I have explained it. It's actually the very same thing, also 1-bit, of course. And there's now also a link between the 4-volt, or let's say the binary input, better said, and the RTC. Why is that? Well, that is a link that we will need in order to detect whether a window is open in the room, yes or no. Because indeed, from the moment let's say the situation is as follows: the room temperature controller is actually put in comfort mode, but at the same time a window is opened. That doesn't make sense, of course, and indeed it doesn't make sense for this function as well, because the room temperature controller can then detect this and puts itself back into safe mode. This in order to save, of course, energy. So that is the entire point of this window open contact. And then, of course, we still need a link between the RTC and the valve actuator. As I said, however, this time a bit different, and that is that instead of switching, we will use a specific valve position, so expressed in percentage, which is actually 8-bit information, or encoded as 8-bit information. That means we can, that the room temperature controller can indeed specifically put the valve into 10%, 15, 55, or whatever is required, whatever is calculated by the RTC as required. That will be the position, the valve position. That will be used via, and that will be set via the blue link or via group address 3. So okay, that was then my part. So I'll now give the floor back to Christian, and maybe later on during Q&A, during the Q&A session, you might hear my voice again. Thank you so far for your attention.
All right, thank you very much, Christoph. Now, that was, let's say, the more theoretical part. I'm very happy now to change the presentation to our KNX member. For that, I'm first going to unmute our guest speaker for today. If I can find it here. Okay, there we go. Okay, Sophia, you're officially unmuted.
Hello, hello everybody there.
All right, we can hear you, yes. And now I'm going to switch the presentation to you. Okay, and now you're good to go.
Okay, hello everybody there. I hope you are now seeing my presentation. Yeah. So this is Sofia from Intesis, and I am here also with my colleague Oriol Cervello, and we will be the responsible today to introduce you a little bit with the air condition systems and the integration into KNX. Just to let you understand, Intesis is the market leader in the air condition integration. So I hope today our know-how will help you to understand a little bit more about air condition integration. So let's start. My agenda for today, I will explain the different types of air condition systems and the different type of controls that the manufacturers have now. Then I will explain how to integrate these systems into KNX protocol and to make you understand why we have different kind of gateways in order to fit the needs with the different type of air condition systems. And at the end, we will give some examples by using the ETS, and we will explain some benefits of using the integration of air conditioning into KNX. So, mainly we have two different kind of systems for the air condition. One of them is the direct expansion and another one is the water systems. What Christoph was explaining in the previous presentation, let's say, is focusing in the water systems. But I have to say that the direct expansion systems are usually more, like you can find more oftenly in your homes or in offices and commercial areas. So it's important to understand what is the difference between these two systems and how you will be able to integrate these systems into the KNX. So the main difference between these two systems is that the direct expansion systems are using refrigerant in order to cool or heat the space, okay? However, the water systems are using, as the name is saying, water, okay? So if you see in the two diagrams that I have here in the presentation, in the DX systems, we can see the refrigerant is traveling around the coil, and then this is the medium that offers the possibility to cool or heat the space, okay? As you can see in the indoor unit, which is the section that we can see inside the home, there is a fan that allows to send air inside the space, and the refrigerant is giving the cool or heat need. However, if we see in the water system, there is a production of water, and the water is pumped to the pipes that we have here. We have heating and cooling pipes, because this is an example of 4 pipes fan coil. So in this case, the water is traveling through the pipes, and we have 2 valves here to regulate the entrance of this water and to regulate the temperature that is entering to these 2 pipes here. And then the air is traveling through these 2 coils here, the heat and cool, and then is sending the warm air or cold air to the space, okay? So the main difference is the medium that you are using, the refrigerant or the water. Also, I have to say that in order to control water systems, as also Christoph explained before in his presentation, you need to install some additional devices. For example, a room unit, a thermostat, to control the temperature of the room and to create the PID control. And you need also an additional controller that can regulate, open and close the valves and switch off or switch on the different fan speeds. However, in the DX system, the indoor unit is self-managed. It means you don't need to create any additional PID control. You just need to send easy commands. It means change the operating mode, like heating, cooling, or send like fan speed 1, 2, or change the set point. And the indoor unit are self-managed. It means all the controls or the regulation is being done by itself. Okay? So, as Intesis, we are focusing in the DX air conditioning systems and their integration. So, I will explain now which kind of DX systems we can find in the market, and therefore why we need different gateways to control all of them. So to start, we have the split systems where you can find the outdoor unit and the indoor unit. Okay. In this case, we also have the possibility to install more than one split in a space in order to create different areas and to have different temperatures. But I want to mention that in these multi-split systems, the operating mode has to be same. I mean, you cannot have one room working as cooling and one room working as heating. No, because the outdoor unit can just work in one operating mode, and that's why, let's say, all the space, all your home, all your office will work in a specific mode. Just to mention, you can find different types of indoor units: the wall-mounted, cassette, floor standing, and ducted. Okay. So we also have the VRF system, variable refrigerant flow, and just to mention, you can see this system as the name of VRV. However, this is a registered name by Daikin, and other brands cannot use this name, so the other brands are using the VRF name, but I have to say that the systems are working exactly same, and you can find the same solution, but they are using just different names. So the VRF is coming into two formats. There are 2 pipes and 3 pipe systems, and the biggest benefit of using the 3 pipes is that it has the ability to simultaneously heat certain zones while cooling others. It means if you have an office with different rooms, and some of them can be cooled and some others can be heated. Okay? As I mentioned before, by using the multi-split, you cannot have this functionality, but by using this system, VRF system, you can have it. In order to make you understand the main differences between the VRF and the multi-splits unit, the VRF system allows longer distances. Why? Because the valve, the expansion valve, is located in the indoor unit, and that's why the refrigerant can travel in high pressure, and that's why this is the reason why the VRF system allows longer distance, and that is why it is a system that is usually installed in commercial areas or offices. However, the splits, for the same reason, because the valve is installed in the outdoor unit, the splits are more silent. So that is why this is a system dedicated to domestic lines, let's say for homes and yeah. So to finalize about the different type of air conditioning systems, we have the air-to-water. The air-to-water is combining the refrigerant system, the direct, the refrigerant philosophy, but also the water systems philosophy, okay? So what we have mainly two units. One is the outdoor unit, which is sending the refrigerant, as you can see here, to the hydro unit. And in the hydro unit, we have a plate exchanger, what is giving the heat or cool to the water. So via this pump, the water is recirculating in the hydro unit, and the refrigerant is heating or cooling this water and sending this water to the systems. In this example that we have here, we can see that the system is supplying water for domestic water, for shower or kitchen or however, and distributing the water also to the floor heating, okay? This is just an example, but you can find different systems connected here. For example, radiators, fan coils, pools, and others. So once we can see all the DX systems that we can find in the market, I have to explain that also the manufacturers have different types of control for the different systems. So we can find mainly three different controls, okay? One of them is the infrared remote controller that I am sure all of you know this. Each manufacturer, however, is using different kind of commands and protocol, and even the same manufacturer sometimes is using different commands by using different kind of remote controls. So there is a really huge variety of remote controllers that you can find in the market. And the second option is to have a wiring remote controller, which is a remote controller that is directly connected to the indoor unit. And the third option is to have a centralized controller, which is, let's say, the manufacturer is creating a bus communication bus, and is installed centralized controller in order to control from this all the outdoor and indoor units from the same point, okay? So, how to integrate all these systems into KNX and how to control them? This is important to understand that we have different systems, but also we have many different brands in the market. So this is not like a fan coil that, okay, we can find different brands, but a fan coil, a water system, is always controlling in the same way. When you see the direct expansion systems, each brand is using different communication protocols, and this is a non-standard communication. So you have to study in detail every brand in order to in order to be able to communicate and to control, and in order to be able to integrate into the standard protocol of KNX. So we have a solution for it, and as we have different type of air conditioning systems and different type of manufacturer type of controls, we also have different type of gateways that is matching with, like, it is giving the solution needed for every situation, okay? So we have the KNX 1 series, which is allowing to control an individual indoor unit. We have the multiple air conditioner units gateways that is allowing to connect to the manufacturer bus or to connect to the main controller of the manufacturer and to control a full installation with more than one unit. And at the end, we also have the KNX 1 Universal, which is allowing to control the individual AC units via infrared commands. Okay, so how these gateways are connected to these systems, to these air conditioning systems? We have the gateway, and then in the KNX 1 AC gateway type, we are directly connected to the AC unit. So we in the split or in the indoor unit, we can find the manufacturer board, and depending on the manufacturer, we are connected to different connectors. For example, as we can see here, for Mitsubishi Electric, we are connected to CN105. For Daikin, S21, Panasonic, and Midea, different connectors, okay? So, as I said, we need really huge range of gateways in order to fit with the market needs. And of course, once we have solved the connection to the AC unit, we have the total integration into KNX by using standard objects and by sending really easy commands to the air conditioning units. As we saw before, we have also the option to have a wire remote control connected to the indoor unit. So we have a solution for this kind of air conditioning system. So what we are doing, we are directly connected to the AC remote controller, okay? For example, as you can see here, for Mitsubishi Heavy, Daikin, LG, Toshiba, Fujitsu, and Panasonic, we are connected to different remote controller connector, okay? And of course, directly to KNX for the total integration. Then we have the centralized controller integration that we connect directly to the manufacturer bus, or we also have the option to be connected to the manufacturer centralized controller. And to finalize the gateways types, we have the KNX Universal, which is allowing to control the indoor unit via infrared communication. It's important I want to explain you that Intesis is the only company that is offering this kind of devices and giving a feedback of the machine. How we are doing this? We are having an infrared receiver, and as soon as the user is changing some commands by using the infrared manufacturer remote controller, we are also catching this command and we are changing the status of the machine into KNX. So we are sending what the user has changed via the remote control to KNX. So you have a real feedback of the situation, even the change has not been done via KNX. Okay, and we have a new feature for this device that is really helpful, and it's giving, let's say, it's helping to integrators and to installer to make a faster and easier installation. Why? Because as you can see here, this is our plugin for our KNX plugin for the KNX IR gateway, and usually we are choosing the AC brand and the model of the remote controller to understand which kind of commands we will send from the device. However, right now, by using this Autolearn button, you will be able to just press a button of the infrared remote controller, and the device will automatically understand which brand and which model of the, the brand and the model of the remote controller. So think how easy and how fast it will be to integrate your remote controller, your infrared system into KNX. Just by pressing one button, we will understand which kind of system you have, and we will just save it, and it will be all. Also, it's important that by using this system, you will also be able to understand that if the remote controller that you have in your hand is compatible with the system or no. If it is not compatible, it means we don't have this remote controller in our database. It will give you a warning that the remote controller is not compatible, but you will just send to us this remote controller, and as soon as we get it, you will be able to find it because we will implement it in our database. So now, as a good feature, a good functionality that our gateways have and that I want to explain in detail is the virtual temperature. Okay, you can find this functionality in the gateways to control a unique, an individual indoor unit. Okay, so in this case, usually, as I say, the indoor units are self-managed. It means they have their own temperature sensor inside. But in the case, of course, in KNX protocol, in the KNX installation that you will find in the project, you must, or you might find a situation that you have the indoor unit, the split, but you also want to use a KNX thermostat, and you want to control the split from the KNX thermostat. And you want to use the KNX temperature sensor, and you don't want to use the let's say, the split temperature sensor. So in this case, we are giving a easy solution. Most of the manufacturers are allowing to directly write the temperature sensor. It means you will be able to give the information from outside. You will be able to say the split that you don't want to use its own temperature sensor. You want to use the sensor from KNX. And in this, so in this way, we are doing an integration from the KNX thermostat to the split. In other case, the manufacturers don't allow to write the temperature sensor. And in this way, we are giving the possibility to use virtual temperature. How? Imagine, as we are showing here, we have the split unit with the sensor and the thermostat with with its own sensor. So usually what you have for example, as an example, we have the 27 degrees and the KNX thermostat is instead giving 26 degrees. So we are saying that the set point that you are sending from the KNX thermostat is 21. We are reading these two values and we are doing a easy calculation in order to fit this set point into the split unit. So as you can see, the difference here between the set point and the temperature sensor is 5 degrees, okay? So when we are sending to the split unit the set point temperature, we are doing this 5-degree difference between the temperature and the set point, and then we are sending to the split unit this 22 degree, okay? So just to mention some benefits of using, of integrate these AC units into KNX, we can have an integral supervision and control of the AC unit from KNX thermostat, touch panels, or APPs. As I mentioned, it is not an easy thing because every manufacturer is using different protocol, and to have this integral supervision into KNX is really an important and a really good point. Also, there is the possibility to have a simultaneous control from KNX and the air conditioners manufacturer remote control. You can also have from KNX a global control of all the indoor units, and you can create a KNX scenes. Also, thanks to KNX signals such as occupancy or window contact, you can launch a series of functions that allow to obtain grid energy savings. Also, because we have bidirectional communication with the indoors, with the indoor units, we can always be monitoring the error information and the alarms from the indoor units. So it means that you will always be aware about the error information, and you will be able to take the necessary actions in the fastest way. So this is for the moment, this is all I wanted to explain about the air conditioning integration and the type of gateways that you need for the control of the different type of systems. And here we are showing our portfolio to see that we really need a specific gateway for each manufacturer and for each type of system. So the integrators and the installers need to understand which kind of system you will find in your projects, and to see which kind of connection you will have in the indoor units, and then we will offer the best solution for each one. And now I want to open the ETS and give you some function explanation, some like how to program our devices and how to integrate this with a KNX thermostat. For this, I have here one of our gateways to control a unique and individual indoor unit, and we have here a KNX thermostat, okay, and a standard KNX thermostat. So I have created here different group addresses in order to control the operating mode, the fan speed, the temperature, and to create a function by using a presence sensor. Okay, so in our gateway, if we are going to parameters, in the configuration mode, we can find that, just a second, I will try to make bigger my screen. Okay, so we have here the parameters, and we can see that we have different kind of objects which is matching with the different thermostat that you can find in the market. So in this case, what I'm using for the operating mode, I have one object here, enable mode cool heat objects, okay, and by using this object and by telling to the room thermostat here in their parameters, in the temperature control, I am saying that my thermostat function is heating and cooling. So I also have here one object in order to change between heat and cool. So by putting these two objects together, you will be able to send from the KNX thermostat the changing between the heat and cooled mode. Okay? And as I mentioned before, the thermostat, the KNX thermostat, are doing the PID control. So, as I said, the indoor units are self-managed, but in order to have an integration with these thermostats, we create a PID signal integration, let's say, that by sending the cooling command and the heating command, which is a percentage regarding the demand of the room, by matching this heating and cooling demand object with our control mode cool and on, what we are doing, as soon as the PID signal is bigger than 1%, we are sending to the indoor unit, switch on and be in cool mode, okay? In the same way, if we are getting a value bigger than 1% via the heating out command, via this object, we are setting the indoor unit in heat mode and also at the same time switching on. Okay, so this is a good integration with the KNX thermostat. For the fan speed, we have the option to control the fan speed by thresholds. So if you go to the thermostat, in the fan speed, in the ventilation part, I define this as 3 fan speeds, and you are defining here the thresholds for the different fan speeds. And by matching this object with our control fan speed threshold, as soon as we get a percentage from the KNX thermostat between this range, we are sending to the indoor unit the specific fan speed that we are getting from the thermostat. In the same way, we can use individual objects by setting one bit object in each group address, and just by sending the value 1 from the thermostat to these specific objects, we are setting the indoor unit in fan speed 1, fan speed 2, or fan speed 3. Here is the configuration that I have already explained for the virtual temperature. So we can get here the AC return temperature. It means we can get the temperature sensor value from the indoor unit, and we can send also this value to the KNX in order to use it if necessary. And also we can send the temperature of the KNX thermostat to the indoor unit in order to control the indoor unit by using the KNX thermostat information. It's exactly what I explained in the presentation. And here to get the set point and the real status of the set point. And just to finalize, I want to explain functionality, a special function that we can find in our gateways, which is the occupancy. Here in special modes, in switch off timeouts configuration, we can enable the use of occupancy function, and then by this way, by using our gateway have 4 binary inputs, so this function can work in 2 different ways. You can directly connect a presence sensor to our binary input, and then this function will work by using this binary input. In this case, for example, input 1, yes, I'm using, and I am selecting in the function the occupancy internal. By doing this configuration, this functionality will work using the binary input. But also, if you want to use an external KNX thermostat, an external KNX presence signal, you can also do it. How? You are enable the function, and then in the objects, you can find here the control occupancy object. So if you put together this object with, for example, a card holder contact sensor that the thermostat that I have here as you can see here in the inputs, I enable the card holder contact sensor of the KNX thermostat, and I put together with my control occupancy object. So in this way, as soon as I get from KNX this card holder information, I will do a series of actions that are explaining here. Just a second. So as soon as I get the signal of there is no presence, The first action is selecting here. For example, I will reduce my set point 2 degrees. And also, if I want, I also can enable a secondary timeout by using this parameter, yes. And I will say that after 20 minutes, if there is no presence, then I will apply a second action that it means, for example, in this case, I will switch off the air conditioning system. So this is how to program occupancy function with our gateway and also an external presence sensor or card holder or wherever you want. And well, this is all for today about the air condition integration. I hope this presentation helped you to understand a little bit about the integration, and please, if you need some more information or if you have any doubt, please contact with us and we will be grateful to help you. Thank you very much for your attention.
Okay, Sophia, thank you very much. That was a very interesting presentation. What I really liked was that we could really see all the different facets of air conditioning and integration control, from the air conditioning side all the way to the integration to the KNX side. So thank you very much for this great presentation. At this point, I would maybe like to open the floor for some questions and answers. So during the presentation, I've seen there were some questions. Are there maybe some more questions at this point? So we have here a question. Can the virtual temperature be implemented by the universal IR gateway device? That is a question for Sophia. Sophia, are you still with us?
Yeah, I am here. Sorry, I was reading the question.
Okay.
Can you please explain again how the data of the third-party units are read out? Okay, so there is not any separate tool. What they are still seeing my screen, Christian?
Yeah, we still see a screen.
Okay. There is no any separate tool. What we are using is the ETS, the standard software of KNX, the ETS, and just you are importing the different products that you will use in your project, and then you are getting the data from one device and sending to the other by using the group address. So what I only did is to create a group address and then to link together, for example, the temperature value coming from the KNX thermostat, which is this object, okay? And I link with the control object of my gateway. So in this way, like putting them together in the same group address, I can be sure that they will be communicating to each other. So I don't know if I answered your question or... You mean that one? Okay. How we are getting, okay, you mean how we are getting the IR command from the remote controller, right? So what we are doing is our gateway, from when as soon as you press the Autolearn button, okay, our gateway, our device will enter in Autolearn mode, and as soon as you press from your remote controller to our gateway a button, let's say on off or fan speed, then the gateway will be able to read this command to evaluate and to give you a feedback about the remote controller that you are using.
Okay, good. Thank you very much for this great explanation. I see we still have like quite a lot of questions here. Maybe we go like the difference between wire control mode and IR control mode.
Just a small answer to Axel. These screenshots are coming from a new feature that will be implemented in our KNX One Universal Gateway in September. So right now this button, this Autolearn button is not available. You cannot see it in our ETS plugin, but you will be able to see it after September or in September with an update that we will do in this plugin.
Okay, good. I think the question was therefore like about the screenshot was answered. I see maybe here also like the question for Christoph about data point types. If I would just direct this question from Andreas to you, Christoph, are there used standard data point types only, or is there a need for non-standard data point types to control the AC system?
Well, I think this is actually a question for Sophia, because I think this question relates to the products, to the portfolio of Intesis here, if I'm not mistaken.
Sorry.
Or is it a question indeed in general from Andreas, Mr. Andreas?
Of course, we are always using standard DPTs. We are using standard DPTs because this is the way that we can integrate with KNX.
Okay. Then I think the question is answered.
Yeah, I think
okay.
That was what I expected as well, yes.
He's right, Andreas is right. Sometimes it's not easy to give all the information to the indoor unit by using standard DPTs because there are so much specific signals. But in this kind of situations, what we are doing is we are trying to use 1 bit standard DPTs, and in this way, by using 1 bit, we can enable or disable some signals that we could use maybe 1 byte, but by using 1 bit, we can solve this situation.
Okay, good. Then I think we have like also the answer to this question. Kyle is asking quite like, let's say, a practical question about his intentions to use the iBox KNX MBRTU-A in his system. We cannot find an ETS file. Can you maybe give your feedback on that question, Sophia?
Yeah, I will answer this question. In case of this particular product, the KNX Member Intesis, it's necessary to use a dummy because the configuration is made by our own configuration software.
Okay, thank you very much. So here, a very Intesis specific question by George. Some new split units have Wi-Fi communication. How do we communicate using Intesis?
We will not use this Wi-Fi communication. We will use the direct connection to the unit. So if the user wants to have both systems, the Wi-Fi communication provided for the AC manufacturer, but also a KNX integration, in some manufacturers it's possible to do both at the same time. in other manufacturers, it's not possible to do both. The user needs to choose between the Wi-Fi of the manufacturer or the KNX.
Okay. Good. I think then like the questions which have been answered here in the chat box have been answered, if I'm not mistaken. Just in case you have like a question that I might have skipped, please write it down now. Has happened. Okay. There we see another question. What is advantage to installer using KNX interface with reference to one-to-one or centralized gateway solution?
Yeah. In that case, okay, it's a topology issue. It's depending what do you want to offer in your installation. For example, you have a building of flats with a BREF system. The BREF system is sharing cooling or heating for all the building, but in that case, the KNX integrator wants to offer a prepaid KNX installation for each flat. So in that case, it's better to use the one-by-one gateways instead the centralized one, because if you use the centralized, this means that then all the flats needs to share the same KNX network, or install couplers, a KNX couplers, and make the setting, and okay, complicate a little bit the topology. So normally in that cases the people are using the one-by-one. Also, there are some more difference because our one-by-one gateways are offering, for example, this the virtual temperature function that Sophia explained you, or are offering direct control of this temperature reference. And on the other hand, the centralized gateways can do it. So there is some difference like this.
Okay, thank you very much for that explanation. We also see like another question for like you, Oriol, regarding the previous point about Wi-Fi versus KNX control. The question is, does Intesis have a list of manufacturers which could help customers if they want to use both options?
I have in my mind, not in writing list.
Okay. Good. So that basically means that Stephen can like send an email to contact you and see like what the options are.
Yeah. This is because, you know, the AC manufacturers has different lines of products, and we work with many different manufacturers, so it's a huge list. But if he has a specific question about one manufacturer, he can guide me and I will answer for sure.
Okay, perfect. So I see the question by George. The ETS example was also part of the webinar, and as this webinar has been recorded, that example that Sophia also showed will also be shared with the participants. So about that you do not have to worry. We will, once the recording has been finalized, we will just like edit it and make it online as soon as possible. Okay, when there are no further questions, I would like to again thank you very much, Sophia, for this great presentation, and also Oriol for like standing here for question and answers. Again, I have to say it was a very interesting webinar, so thank you very much for that. And before I end this webinar for us all, I would like to give the last word to you, Sophia and Oriol, to the audience.
Okay, just thank you very much for everybody to join us in this webinar, and I really hope this was helpful for you to understand a little bit about the AC integration into KNX. And as I said before, please contact with us for any question or any assistance. Thank you. And also thank you to you, Christian, for everything.
Okay, thank you. Then at this point, I would just like to say again, thank you very much to all of you. If you have any questions, feel free to contact KNX Association or Intesis directly. And as of now, I would like to wish you all a happy and great day today on the day of summer. And I am looking forward to hearing again from all of you. Thank you very much and see you next time. Bye-bye.
Bye-bye.
Bye-bye.